All right, for our last section in this triangle chapter, we're going to be finding the area of a triangle. And these triangles do not have to be, they're not right triangles, they're just oblique triangles. Um, and there's two different formulas we're going to look at depending on what information that you have. The first one that we're going to look at is the formula you're going to use if you have side, included angle, and side. So that means you have to have the angle in between touching the two sides. So for side, included angle, and side. Okay, so that means if you have side A and B, you would have angle C, the one in between those two, not the one across from it. And so the formula, if you have side, included angle, side, is as follows. Area equals 1/2 side times the sine of the included angle. And so the sides and the angles could switch up depending on if you have A, B, or C. So 1/2 side, and sine of the included angle. So that could mean you could have areas 1/2 B times C times the sine of A, or 1/2 A times C times the sine of B, or 1/2 AB times the sine of C. Okay, any of those combinations. If you are given information that doesn't give you side, included angle, and side, then you might have to use law of sines or law of cosines to find that included angle. All right, so let's look at an example. So we have A, B, C. Say this is 120 degrees. And that this side is 3 units, and this side is 10 units. So this is a side, included angle, and a side. So the angle in between these two sides. If I had given you like angle A and these two sides, then you would have to use the law of sines to find this angle C. You'd have to have the included angle for this formula to work. Once you do, then the area is just going to be 1/2 the one side times the second side times the sine of the included angle. So 120 in this case. All right, all of that goes into your calculator. So 1/2 times 3 times 10, so it's 15, times the sine of 120. And so my area is about 12.99 units squared, or about 13 units squared. Okay. Again, major key is you must have the angle in between the two sides. Okay? So that works for side angle side. The second formula is what you use if you just have side, side, side. So if you know all three sides and no angles, use this formula. Okay? So the area formula, if you have side, 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 is square root of s times s minus a times s minus b times s minus c. All right, where s is the perimeter, a plus b plus c, divided by 2. So add up all the outside edges and divide that by 2. Okay, so let's look at an example. The triangle where I have ABC. Let's say this side is 125 feet, this side is 280 feet, and the third side is 315 feet. Alright, the first thing I'm going to want to do is I'm going to find the S. So I'm going to take the sum of all of those, 125 plus 280 plus 315, and I'm going to divide that by 2. So into the calculator, 125 plus 280 plus 315 is 720. Divide that by 2. I get 360 is my S. Okay? And then you're going to take that 360 and put it in where all the S's are. And then the A, B, and C are the lengths of side A, side B, and side C. So our area here is going to be the square root of 360 times 360 minus the first side, which is 125, times 360 minus the second side, which is 280, and 360 minus the third side, which is 315. All right, so all that goes into your calculator. Okay, and I'm going to get underneath the square roots 304560000. So 304,560,000. And then if you take the square root of that, we come up with the area of this triangle. And the area of this triangle is 17,452 square feet. Okay? So you're going to use this formula if you have all three sides. Called Heron's, actually has a name, Heron's formula, where the S is the perimeter divided in half the perimeter, A plus B plus C divided by 2. A, B, C are the lengths of the sides. And if you have side included angle and side, then you can use this formula, 1/2 the first side times the second side times the sine of the included angle.